Okay, let's go ahead and plot these things. So negative 8, negative 6. Negative 8, negative 6 is somewhere right here. Negative 3, negative 9, or negative 3, 9 would be up here. And 6, 5. 6, 5 is right there. So this one was P, this one is Q, and this one is R. Then it says go ahead and draw PQ, RQ, and RP. So go ahead and draw those. Not very straight. Okay, there they are drawn. What's the distance from P to Q? So in order to find from P to Q, I'm going to turn it into the Pythagorean theorem. Go ahead and make these legs come up there. Now I can count those, but I'm going to make sure I count them correctly from P to Q. So I'm going to look at the tallness, the y part. So the y for that one is got something to do with the 6 and the 9. So it's either a 3 or a 15. Well, it's obviously not 3, so that must mean when I counted I would get 15. And then the sidewaysness, there's the x and the y value. So if I add those digits, they're 11. Subtract them, it's 5. That's either 11 or 5. 1, 2, 3, 4, 5. That's just a nice way to check if you counted right. Okay, now we can get the Pythagorean theorem working on that one. So we have c squared is equal to 15 squared plus 5 squared. That's a 5. So 15 squared is 225. 5 squared is 25. So c squared equals that. So we've got 225 plus 25, so that's going to be 250. So c squared is 250. Square rooting both sides gives us the square root of 250. That's the exact value. What's the distance from Q to R? So I'm going to do the same thing for Q to R. I'm going to go from there and to there. So I'm going to Pythagorean that one out. So when I count that, Q and R now. So the sidewaysness has to do with that negative 3 and that 6. So it's either 9 or 3. So when I count that, there's no way it's 3, so it must be 9. And then the y values, it's 9 and 5, so that's either going to add up to 14 or subtract to 4. 1, 2, 3, 4. So that's going to be 81 plus 16. So now we have c squared is the 9 squared plus the 4 squared. That's where I got 81 and 16. So that's 97. So then when I square root both sides, it's the square root of 97. That's how long Q to R is. And then the last one wants us to find the perimeter. Well, it's going to be this 250. That one right there was the root of 250. That one was there's the root of 97. So I need this last one, P to R, so I just need to do this one more time and find that one. So now I can count across there, or I can probably see it up here. All the way across the top was 14, so all the way across the bottom would be 14. The side was 15. Well, that much of it is 4, so that much must be 11. That would be one way to do it. Or you could count it, or you could get it from the x and y's up here. But it's 14 and 11. Okay, so that should allow us to get PR. So now we have c squared is equal to 14 squared and 11 squared. So you can type this in your calculator if you need to, but 14 squared is 196. And 11 squared is 121. So that distance right there, 196 and 121 is 317. So that means that distance is the square root of 317. So the perimeter. It's going to be the root of 250 for the first edge, plus the root of 97, plus that last one, this one here, which would be the square root of 317. Okay, get your calculator out. Okay, so let's type that in. So it's going to be the square root of 250. Close that one, plus the square root of 97. Close that one, plus the square root of 317. Rounding that to the tenths place would be 43.5.